Slalom ski construction and design, what I think is important for a ski. And one of the most important things I think about a ski is its core technology and how it's built. So the most extreme example of that is the warp ski, which is an air core, carbon over air core. And that ski provides unmatched feel on the water. And how it skied is the most direct connection with the water I've ever felt in a ski. So if the core is closest to air, very kind of a stiff light core, almost like a styrofoam or even a flutterboard, then I think the ski is going to react better as you add the carbon into it. So carbon's really stiff and light, of course, and then if the core is stiff and light, the two add together and produce a really good ski. And the next thing on the ski is I think what's really important is the rocker of the ski, because that's how you're going to set on the water. So when you ride the ski between your 2 feet, it's almost like a skate blade. You're going to sit balanced on the ski, and you're going to be able to get on your front foot or get on your back foot kind of seamlessly through the turn and through the pull. And more rocker, the ski's going to sit deeper in the water. If it has more rocker, the ski's going to sit deeper in the water. And if it's got less rocker, it's going to tend to ride higher and be faster. So a slalom course is kind of a blend between turns and pulls. So a ski with a little bit more rocker is going to turn faster and sit a bit deeper in the water. A ski that's flatter is going to pull better, but it's going to be more difficult. It's going to probably carve a tighter, longer radius turn course. So it's a bit of a balance between that. And of course, the flex of the ski, a softer ski sits deeper in the water because it builds more rocker to stand on it. And a stiffer ski is going to be quicker because it's going to maintain its rocker profile under load. And the bevels, I don't think bevels make a difference in terms of, like, if you have a round edge bevel, kind of a softer bevel like this ski, in this kind of water, and at 36 miles an hour, it's going to set in the water a little nicer than a sharper edge bevel. But if you're in Florida and they got that soft, soupy water, then you're going to want sharper bevels and a ski that's going to float a bit higher, so it'll be faster, kind of the faster thing. Because what happens is, in a soft water, when the ski kind of washes around or slides around, drifts around, it goes a lot faster turning. That whole process of turning a ski is a lot faster in softer water. You can really drive the ski around. It won't fly out on you. So the turn is quicker and you have more time to get across course. And when you get across course, you're getting across course faster as well. In this type of water, the turns aren't as fast. The water's a lot more firm. Even at 34 miles an hour, it probably skis like 36. So the turns aren't as fast. You take more time in the turn. You don't have as much time to get cross course. So a ski with that turns a bit better, has more rocker, is softer, is better for the firmer water. And then another thing that we do is, or that I've run for years, is this plastic fin block, which is made out of acetyl, and then so it keeps the tail light, and then the tail can flex wherever it wants to. There's no inhibition of tail flex. If you have a big aluminum block there, that's kind of silly. It's the same as in the tip of the ski. What I like about this ski is the tip is a conventional kind of an airfoil type tip, and there's you're going 36, 35 or 55 kilometers an hour, 34 miles an hour, 36 miles an hour. And then, of course, when you're crossing the course, you're going faster. And there's a lot of airflow that happens across the tip of the ski. So I'm not a big fan of these kind of cutout tips. If it just has a simple top like this, and this is a bit convex, and it creates a little bit of lift for you. And just one note about the fin. It doesn't really matter where the vents are. I mean, ultimately it's just how much metal I have in the water. So that's why I can cut a vent that says FM, like that. And it's the same surface area as a hole. So this is like a 4-hole fin, or maybe two holes. But anyway, it's the same surface area as if it was a 5-hole fin. And it actually operates like that. The little leading edges here, as a ski starts to drift, we'll pull the tip down slightly, but it's not that pronounced. The effects aren't that pronounced. So hey, it's a quick little video about ski construction and what I've found over the years.